Welcome to Miss Taylor's video, and today we're talking about application problems, which is just a fancy way of saying word problems. So let's just get into it and let's figure it out. So the junior class at Summerfield High School sold a total of 375 tickets to their spring festival. The adult tickets sold for $7.50 and the student tickets sold for $4.50. They collected $2,212.50 in ticket sales. So when we see a problem like this, the first thing we want to find are our variables. What two things are going on in the problem? And so the two things there are is adult tickets and student tickets. So adult tickets, and then we have student tickets. Oh, I definitely spelled that wrong. So now we need to figure out how much is an adult ticket and how much is a student ticket. So they tell us that adult tickets were sold for $7.50. So 7.5 equals adult. And then it tells us the student tickets. I think student is spelled wrong there. I think it's supposed to be S-T-U-D-E-N-T. Anyways. And so our 4.5 equals our student ticket. So the next thing we want to look for is we want to look for the totals. So what totals do we have? So they sold a total of 375 tickets. Tickets sold. And then they collected $2,212.50 is our total money. So the way I always try to explain this is money goes with money. Let me actually add dollar signs there because that's money. So if I have three things that are money, so I have adult tickets. So I'm going to put 7.5 because that's how much our adult tickets are worth, and use letter A, plus our student tickets, which is 4.5. I'm going to use a fancy S, and the total is $2,212.5. So this is money for adult tickets, money for student tickets, and then the total money. And so that's kind of how I go with that. So once I have used this, and this, I'm now left with three things. I'm left with the total tickets sold, so 375 equals, and they sold two types of tickets, A plus S, adult plus student. So now we have two equations that we can now solve to find a solution. Today, we're really not going to focus on the solution because we've spent a week and a half working on solutions. If you really want to, you can use those two to find your solution, and then we can you can check it with the completed class notes. All right. So today, let's look at our next one. A television weighs 50 pounds and a microwave weighs 30 pounds. A TV occupies 4 cubic feet and a microwave occupies 3 cubic feet. A truck is carrying 1,500 pounds of cargo that occupies 138 cubic feet of space. So the two things we kept talking about were a microwave and a TV. So I've got values of variables. So my microwave, I'm going to abbreviate that MW, weighs 30 pounds, and it takes up 3 cubic feet. So again, microwave, 30 pounds, microwave, 3 cubic feet. And then we have our TV is 50 pounds. And our TV occupies 4 cubic feet. So they then tell us that the truck can carry 1,500 pounds of cargo, so 1,500 pounds, and it has 138 cubic feet. So again, just like the last problem, money goes with money. Here, pounds are going to go with pounds. So I'm going to call my microwave X. I'm going to call my TV Y. And so when I write this equation, pounds with pounds. So a microwave, or my X, weighs 30 pounds. I'm going to put 30 next to X. Then I know that my TV weighs 50 pounds. Oh, no, not 50Y. And then the total pounds in the truck is 1,500. And so that's equation 1. So if pounds go with pounds, then I need cubic feet with cubic feet. So a microwave, which is my X, is 3 cubic feet, plus my TV, which is 4 cubic feet. My TV is my Y. And then the total in the truck is 138 cubic feet. So now we have our 2 equations. And if you want to, you can solve them. But again, today our focus is really writing that equation because we should be pretty good at solving equations. All right. Miguelito's restaurant has a table that sits 6 people and booths that seat 4 people. The restaurant has a total of 38 seating units that will fit a total of 188 people. So our variables are going to be tables and booths, because those are the different types. So we have tables and we have booths. Those are the 2 different things it's talking about. So our tables have 6 people. And then our booths are 4 people. So our totals is 38 seating units. So 38 units, or 188 people. So again, money goes with money, pounds go with pounds, cubic feet go with cubic feet. So people are going to go with people. So if I know that tables seat 6 people, and I know that booths seat 4 people, and the total number of people in the restaurant is 188. So I've used this, I've used this, and I've used this. So now my last equation is everything that's left. So the number of tables plus the number of booths equals 38. And so these are our 2 equations. And then we can use these 2 equations to find the solution. And again, that's not our goal today. Our goal is just to write the equations because we should know how to solve these equations. All right, our last one. Mr. Bro bought 8 tickets to a chili supper and spent a total of $30. He bought a combination of adult tickets for $5 each and child tickets for $3 each. So here our variables are child tickets and adult tickets. So we know that the value of our adult tickets, so A equals $5, and we know our value of our child ticket, or C, equals $3. So the totals that Mr. Bro spent was he bought 8 tickets and he spent $30. So again, money is going to go with money. That's our first rule, money with money. So if our child ticket is $3, our adult ticket is $5, and the total money spent was $30. So that's going to be our first equation. So I have used the 3, I have used the 5, I have used the 30. So my adult plus my child equals $8. And those are my 2 equations.